Hello everyone. In previous lecture we have discussed about carbon resistor, color code of carbon resistor, series and parallel combination of resistor. In today's lecture we are going to discuss about internal resistance of cell, potential difference and EMF of cell. First of all, we are going to discuss what is meant by cell. An electric cell is a device which converts chemical energy into electrical energy. It is also called as electrochemical cell. A collection of two or more cells which is connected in series or parallel is called as battery. Every cell has a two terminal. Positive terminal of a cell is also called as anode. Negative terminal of a cell is also called as cathode. These electrodes will dipped in an ionic solution called electrolyte. It is a liquid which is ionized and conduct electricity. They are also called as electrode of a cell. Next we are going to discuss types of cell. There are different types of cell available and some of the cell given below. First one, electric cell, fuel cell, primary cell, secondary cell, galvanic cell, photovoltaic cell, solar cell, storage. Next we are going to discuss what is meant by primary cell. Primary cell is a cell which cannot be recharged again. It can be used only once. The chemical reaction will be irreversible. The active material may not return to their original state in a primary cell. Dry cell, alkaline cell, mercury cell are an example for primary cell. The primary cell is low cost and can be used easily. They are not suitable for heavy loads. Next we are going to discuss what is meant by secondary cell. Secondary cell can be charged again, so it can be reused again and again. The chemical reaction of secondary cell is reversible. Lead acid cell and fuel cell are example for secondary cells. A car battery and standby power supply are secondary cell. The solar cell are a secondary cell which convert light energy into electrical energy. Though the cost of secondary cell is very high when compared to primary cells. Next we are going to discuss cells in series combination. Let us consider the three cells which are connected in series. The cells are connected in series when they are joined end to end so that same quantity of electricity must flow through each cell. In series connection, the negative terminal of first cell is connected to positive terminal of second cell. The negative terminal of second cell is connected to positive terminal of third cell. The free of positive terminal in the first cell and the free of negative terminal in the last cell become a terminal of a battery. Let epsilon 1, epsilon 2, epsilon 3 be the EMF of a cell. Let R1, R2, R3 be the internal resistance of a cell. Let current I be the flowing through each cell. The total EMF of a battery is equal to NE, where N is equal to number of identical cells. The total internal resistance of a battery is equal to NR. The total resistance of a circuit is equal to NR plus R. Current I is equal to total EMF divided by total resistance. The equation can be written as I is equal to N epsilon divided by NR plus R. If R is less than NR, then I is equal to E by R. If NR is less than R, then I is equal to N of E by R. When internal resistance is neglected to compare with an external resistance, as the cells are connected in series to get a maximum current. Next we are going to discuss cell in parallel combination. In parallel combination, all positive terminal of cells are connected together. All the negative terminals of cells are connected together. The electric resistance is connected between these 2 points. These 2 points form positive terminal and negative terminal of a battery. In parallel connection, the current is splitted among each branch. The current I is splitted into I1, I2, I3. The total current I can be written as I is equal to I1 plus I2 plus I3. The EMF of a battery is same as that of single cell. The reciprocal of total internal resistance is sum of reciprocal of individual internal resistance of a cell. The total EMF of a battery is equal to E. Total internal resistance of a battery is equal to R by N. The total resistance of a circuit is equal to R by N plus R. The current I is equal to total EMF divided by total resistance. I is equal to NE divided by NR plus R. If R is less than R by N, then I is equal to N of E by R. If R by N is less than R, then I is equal to E by R. For a parallel combination of cell, if any one of a cell in a circuit is damaged, then it will not affect the whole connection. Next, we are going to discuss internal resistance of a cell. The obstacle offered by an electrolytic of cell in the path of electric current is called internal resistance of a cell. A battery is made up of electrode and electrolyte to opposes the flow of electric current. It is denoted by a symbol R. It causes voltage drop when electric current flow through internal resistance of a cell. For a real battery, the terminal voltage must not be equal to EMF of a battery. For ideal battery, it has zero internal resistance. The potential difference across a battery must be equal to EMF of a battery. Next, we are going to discuss determination of internal resistance of cell. First of all, the EMF of a battery is measured by connecting high resistance voltmeter across it without connecting external resistance R in the circuit. Since the voltmeter draw very small amount of current for deflection, then the circuit may be considered as open. Hence, voltmeter gives the EMF of a cell. Here, the external resistor R is included in a circuit and current I is established in a circuit. The potential difference across a resistor is equal to potential difference across a battery or EMF. The potential drop across resistor is given by a formula V is equal to IR. Due to the internal resistance of a cell, voltmeter gives a value V, which is less than the EMF of a cell. This is because certain amount of voltage drop has been occurred between the internal resistance of cell. The equation can be written as V is equal to epsilon minus IR, IR is equal to epsilon minus V. Dividing the equation 2 by equation 1, we get IR divided by IR is equal to epsilon minus V divided by V. We cancel II, so the equation can be written as R by R is equal to epsilon minus V by V. R is equal to epsilon minus V divided by V into R. Since epsilon, R and V are known, we can find the internal resistance value R. Internal resistance of a cell depends on the following factor. It is directly proportional to distance between the electrode. It is inversely proportional to facing surface area of electrode in electrolyte. It is inversely proportional to concentration of electrolyte. When the resistance of cell decreases with increasing in temperature of electrolyte, the internal resistance of a cell depends on the nature of electrode. Next, we are going to discuss about potential difference and electromotive force EMF. It is a potential difference between two terminals of a cell. When it is a closed circuit, the current I is flown. It is represented by a symbol V. Its unit is volt. Next, we are going to discuss electromotive force EMF. Electromotive force is defined as potential difference which is established between two terminals of a battery when it is in an open circuit. It is a device which converts any form of energy into electrical energy, which is measured in 1 coulomb of charge. We know that anode has a positive potential V plus and cathode has a negative potential V minus. The EMF of a cell is given by an equation EMF is equal to positive potential minus negative potential. E is equal to V plus minus of minus V minus. E is equal to V plus plus V minus. Therefore, EMF is a potential difference between positive terminal anode and negative terminal cathode when no current I is flowing through it. It is represented by a symbol E. Its unit is volt. It is a scalar quantity. Electromotive force is given by a following equation. EMF E is equal to I into R plus R, where I is equal to current which is measured in ampere. R is equal to resistance of a load in a circuit which is measured in ohm. R is a total internal resistance of a cell which is measured in ohm. EMF is equal to E by Q, where E is equal to energy which is measured in joule. Q is equal to charge which is measured in coulombs. Next, we are going to discuss difference between potential difference EMF. First EMF, then potential difference. EMF is defined as a work done on unit charge. Potential difference is defined as the energy which is dissipated on unit charge which is passes through the one component. EMF will remain constant. Potential difference is not a constant. Due to EMF, electric field, magnetic field, gravitational field is caused. Due to potential difference, only electric field is induced. EMF is independent to the resistance of a circuit. Potential difference is directly proportional to the resistance between two given points. It is always greater than potential difference. It is always lesser than EMF. EMF transmit current both inside and outside the cell. Potential difference transmit a current between two given cells. EMF is measured by a potentiometric method. Potential difference is measured by a voltmeter. EMF has a constant intensity with a greater magnitude. Potential difference has non-constant intensity with lesser magnitude. The term EMF is used only for source of current. Example, dynamo and battery. The potential difference can be measured between two terminals of a cell. Example, battery. We have come to the end of a section. I hope you all understand the today topic, internal resistance of a cell, potential difference, EMF of a cell. In the next lecture, we are going to discuss Wheatstone bridge. Thank you.